Vacuum casting, also known as vacuum duplication, is a manufacturing process that delivers both high precision and excellent surface quality. Its core principle involves injecting liquid resin into a silicone mold under a vacuum environment, allowing the material to fully fill intricate details and produce high-quality parts. Vacuum casting is ideally suited for small batch production, prototyping, functional testing, and appearance validation. Its key advantages include excellent surface finish, superior material properties, and the ability to reproduce fine details with high fidelity. Vacuum casting fills the gap between 3D printing, which is best suited for very low quantities, and injection molding, which is ideal for high-minus volume production. When 10 to 50 highly realistic, ready-minus-to-minus test parts are required, it is often the most cost-minus effective option. The first step in the process is creating the master pattern. The master pattern, which serves as the prototype to be replicated, is typically produced using 3D printing or CNC machining. Step to fabricating the silicone mold. The master pattern is secured inside a casting box. To gassing the silicone, liquid silicone is placed under vacuum to eliminate entrapped air bubbles. Pouring out, the degassed liquid silicone is poured into the casting box, completely covering the master pattern. Curing the silicone is allowed to cure until fully solidified. The cured silicone mold is carefully cut open, and the master pattern is removed. Finished mold. A flexible silicone mold is obtained, ready for the vacuum casting process. This type of mold can replicate complex geometries, though its typical service life ranges from 15 to 25 casts. The next step is to prepare for casting. The closed silicone mold is placed into the casting chamber of the vacuum unit. Meanwhile, the 2- component polyurethane resin is heated and mixed. The formulation of this resin can be flexibly adjusted to replicate the properties of materials such as ABS, polypropylene, rubber, and even transparent plastics, demonstrating that a single process can deliver a wide range of possibilities. The core step: vacuum casting. The vacuum chamber is sealed and evacuated to a high vacuum state. At this point, the mold cavity is also under vacuum. The mixed resin is drawn into the mold cavity through the pouring tube by vacuum pressure, rather than being forced in under positive pressure. With no air present in the environment, the resin flows unimpeded into every detail, completely eliminating the risk of entrapped air bubbles or incomplete filling. After filling, the vacuum is maintained for a period to evacuate any micro- bubbles generated during the chemical reaction, ensuring a dense, void-free pot. Step 5: Curing and demolding. After casting is complete, the vacuum valve is closed, and the mold is allowed to cure, either at ambient pressure or in an oven. Silicone molds offer good thermal conductivity, resulting in fast curing times. Once the resin has fully reacted, the silicone mold is cut open, and the finished part is removed. Because polyurethane does not adhere to silicone, the part surface is clean and smooth. Only minimal trimming of the sprue is required before the part is ready for use. The essence of vacuum casting can be distilled into a single sentence: gravity casting, using a flexible silicone mold under vacuum conditions. This process delivers high- quality parts with remarkable speed and flexibility. Whether the need is functional testing, market demonstration, or small- batch production, is speed, quality, and low tooling cost are your core priorities. Vacuum casting is the answer.